Hello, my name is Jim Muncie with Projetech. I'm going to provide you with a Maximo version 7 calibration overview. This presentation will provide you with an overall feel for how the Maximo calibration functionality works. There are numerous applications working together that make up this functionality. This is not designed as a training presentation, but merely as a demonstration type of overview. Objectives. Overview of the Maximo calibration applications, and those are organization, locations, assets, job plans, data sheets, preventive maintenance, tools, stock tools, and work order tracking. I will explain how the loop calibration works. I will show you how the job plan, asset, and data sheet are associated together. We will walk through a calibration completion, and then we'll show the calibration history. Some terminology we need to know before we get started. Datasheet Template. That is a Maximo application where the calibration points are listed along with their associated set points. A calibration standard is a high accuracy instrument used to measure the calibration points. That can be a high accuracy gauge, a multimeter, specific calibration instrument, or it could be a decade box. In Maximo, calibration standards are set up in the Tools Cal application as a rotating item. M&TE. That's measuring and test equipment. This checkbox in Maximo on the tool record and asset record denote that these records are calibration standards. Loop calibration is a collection of instruments that are calibrated as one instrument to verify they all function within prescribed limits. For example, a pressure monitoring panel may consist of a pressure sensor, transducer, transmitter, and indicator. In Maximo, a location record is denoted as a loop by a checkbox. The individual components are normally associated to the loop calibration records as assets. Calibration point is a defined test point that accurately calibrates an instrument. Calibration points are numeric and unique. The amount of calibration points specified are based on what is required to calibrate the instrument. And discrete point. This is the set point at which a discrete device, such as a switch or alarm, will actuate. We will begin this calibration presentation by going over some of the various calibration applications within Maximo. To start, we will click on the Go To button and then select Administration, and then go down to where it says Organizations Cal and select that. We'll find our specific organization. In this example, we'll pick on Eagle North America and select it. Once you've selected your organization in the Organizations Cal application, you go to Select Actions. Here there are a number of options you would need to set up prior to beginning any use of the calibration functionality within Maximo. These are set up based on your organization's business processes. So go down toward the bottom under Select Actions and you have Calibration Options. And we'll talk about the first one here, which is Work Order, Other Organization Settings. We'll open it up, and here there are a number of different default functionality you can set up. And the first one we'll talk about is the default amount allocated to extend date in PM Cal application. This refers to how many times you can extend the due date for a calibration PM without requiring a supervisor's approval. That's normally defaulted to 1. Under the work order tracking options, you've got tolerance warning for exceeding limits. And your options are to validate once per save, validate upon tabbing from the output field, or never validate. You have an option for qualified technician. You can either have no validation between the tool and the technician, validate but with a warning message only, or enforce validation between tool and technician. Next, we have validation of tools and work orders. You can either have no validation between the tools and status of closed or complete on a work order, validate but with a warning message, or completely enforce validation between tools and status of closed or complete. Next, we have the validation of rotating asset on work orders. Either you have no validation between the rotating asset and the asset being calibrated, or you validate but with warning message, or you enforce the validation between rotating asset and the asset being calibrated. This prevents you from calibrating an instrument with the same instrument. Other options are to automatically approve tool transactions. That's normally defaulted as checked. Warning message for work order data sheet changes. Prevent past due tools from being entered. automatically set the as found and as left statuses on the work order. And last couple of options refer to the mobile calibration. And those are the options available for me under the other organization settings. I'll cancel this to get out of it. And I'm going to go back to select actions and back to calibration options. And my other option is my work order edit rules. We'll select that now. Under work order edit rules, it's very similar to your normal work order edit rules. Based on the status of the work order, you determine what can be edited. Whether or not I can edit the as found and as left readings, I can add a new data sheet to the work order, or edit the calibration points. You check the boxes for the statuses you want to be able to edit those particular functions. We'll click cancel on this. And that's pretty much all of the organization's Cal application. Let's click on Go To. And we'll slide down to Assets and slide across to Locations Cal. Now, you'll notice here that all of the calibration applications have the same name as the standard applications, but they have Cal in parentheses afterward. So you'll have a Assets and Locations application, but a separate application for Assets Cal and Locations Cal. This is has pros and cons to it. I've seen some sites where they do not use any of the standard applications. They only use the calibration applications. They're basically just another mask into the same data tables within Maximo. So they do that to reduce the amount of applications that require validation. That's especially important for regulated industries. What you'll end up being if you use all the assets applications is you'll find there are a few more features in each one and a few more fields that just would not apply to, say, a standard pump or a motor. So their logic is I can reduce my number of applications being validated and used, and if you're pulling up a record that is not calibrated, those fields just don't apply and you leave them blank. Now, the other school of thought in this is by having separate calibration applications, I can restrict via security who has access to these calibration applications or not. So it's an easy way to differentiate the people in the calibration security group from the other maintenance groups as to who can see what information. But we'll take a quick look at the Locations Cal application. I'm going to open up a record. I have some bookmarked here to look at. This is a example of a loop calibration. Now, loop calibrations are set up in the Locations application. You'll create the location as your loop. And if you check the box down below here for loop calibration, then it indicates that this is a loop calibration. It's pretty much a standard location record. It's got a few additional fields such as the next calibration due date and due date extended fields. And there are a few additional select action options for you for calibration. And we'll take a look at those. If I click on select actions, and down toward the bottom, I got a few different options here. One is I can attach data sheets to this location. The other one is my view calibration history. I'm going to click on the view calibration history and take a look at what functionality we have in there. And I get this view calibration dialog box. Before you see any information, you must specify a date range. So I'm going to click on the date from and give it a starting date about the middle of October. I'll go back a month and select October 11th as my start time or start date. And I'm going to leave the end date open. That way I'll get a full range from that date on forward. And I'll click the refresh button. Now, I'm seeing under two tabs here, locations calibration, location calibrations, and also loop calibrations. And this tells me every work order ever written, every calibration work order ever written against that particular location. And it shows me the actual date it was finished, the data sheet used, if there was an asset associated to that data sheet, the location, and my as found status and my as left status, and whether or not an adjustment was made. And these were required data sheets. So I have a number of points here already, and if I select one, I'm selected the first one right now, I'll select on the work order 1175, next one below that. And when I select that particular work order, I can scroll down below and see all the calibration points that were used in that calibration. There's my nominal input, desired output, as found input, as found output, and as left input, as left output. All my calibration points. I can also, if I had any function checks on the data sheet, this had one function check on it, I'll see that. or this case I didn't have any function checks. You don't see any right here because it wasn't on that work order, and also dynamic checks. These function checks or dynamic checks can be used for calibration, but they're not required. So sometimes you see them used, sometimes not. You almost always see calibration points used. So these are my calibration points. It captures my entire history. If I click on Loop Calibrations, it shows pretty much the same information if it's a loop that you're looking at. And these are all my same work orders for that loop. So I can select any work order I want to and see all my calibrated data points below that. It's part of my view calibration history. I'll click OK to make that go away. And those are the main differences on the locations cal application. Now I'm going to click on Go To. We'll slide down to Assets and go across to Assets Cal. Take a look at that. And I think I saved some records up here, my bookmarks, for samples. Okay, now this is a standard analog temperature indicator. It's just a standard asset record. On top up here, it's the same asset details. What's different is down below, this second section is called Calibration Details. These are all calibration specific information. Now, they're not all required. Some are optional. You can set up a vendor, calibration vendor, if this were calibrated by an outside source, or you can check off if it's internally calibrated. If it's a buffer solution. A buffer solution is sometimes used for things such as pH calibrations. It's a solution you get that's already calibrated to a certain value, and I'll use that to perform other calibrations. Is M&T is very important. That means, is it measuring and test equipment? If that box is checked yes, that indicates that this asset record belongs to a calibration standard. And there's also classifications for the measurement and test equipment, such as primary standard, secondary standard, and a few other ones. You have a checkbox for is contaminated. This primarily is used sometimes in chemical plants. A lot of times it's used in nuclear power plants because they do have some calibration done in radioactively contaminated areas, and the equipment must stay in those areas. So that indicates if it's contaminated or not. Other things you have as far as next calibration due date, this comes from your PM record. Due date extended, asset department, loop number if it's tied to a loop, and other accuracy information down below here. Those are pretty much my calibration differences in the screen. So if I wanted to pull up a pump in this application, I would see all my asset details. I just wouldn't see any of the calibration details because they would not apply. Now, if I go to select actions, I'll see a few more things. I've got some other options such as tool usage, and I'm going to click on a tool usage to see if I have any information in here. And I can select my from and to dates. I'm going to go back again to probably beginning of October. You have to give it a range. Select the from date, and I'll click the refresh button. And no information to show here. What I would normally see is if I had information in here, and this is a demo database, so I don't have a lot of information, you can see the work order, description of the work order, actual finish, asset, and location. Now this refers to the tool usage that this tool may have been used on. This really applies more for calibration standards than for a calibrated process instrument. I'll cancel that out. And let's see, under select actions, we have a few more options. I've got, I can add the, I can always attach a data sheet to it. I can view the spot check history. This applies more to tools as well, or calibration standards, where I may go out in the field and do a quick spot check on the standard before I use it to perform a calibration. I'll be able to see the spot check history. Also, my view calibration history is very similar to what we saw in locations. Let's take a quick look at this one. And I guess you have to give it a from date. Go back to October. I'll select my from date and click refresh. And there's my entire calibration history. Every work order ever performed on that particular asset. And I can see the work order number, all my basic information on top up here. I see my as found as left stats if it's passed. Down below, I can see my actual point readings. And the same calibration history as you saw for locations. Click OK. And that's my tour through my Assets Cal application. Now going on down, I'm going to click on Go To. And we'll go down to Planning. Slide across to Job Plans Cal. And we pull a sample out here. I made this sample up. It's a job plan for a loop calibration. It's very important to standardize your descriptions up here because it makes it much easier to search for these job plans later on. And this is basically for a temperature instrument. And all my standard information is all there. What's different so far? Not really much at all as far as calibration goes. I'll have on my Tools tab. This is a little change here. On my Tools tab, I'm actually adding a tool which is a calibration standard. I'm specifying that I must have this particular calibration tester to be used to perform this calibration. Now, there may be many of these calibration testers in a calibration shop. So when I get to the work order, I'll have to have this tool in there, but then I'll have to specify which specific standard was used on that calibration. That's very important. Now, the other very important thing about job plans is in the Work Assets tab. We'll click on Work Assets. This is extremely important because the Work Assets tab of Job Plan is where you combine the job plan to the specific calibrated asset or location and to the data sheet. This is where you make the link between all three of those, job plan to the work asset to the data sheet. Now I'm selecting right now the location by itself. That's my loop. And I'm saying this loop with this job plan uses, basically I set up 4 different data sheets for it. Now that's because loop calibrations are different than standard calibration on one instrument. I've also set up examples where I've got, on my second one here, I got my temperature transmitter. When I select that temperature transmitter, I'm saying that this job plan and that temperature transmitter goes to this specific asset sheet. And most of your assets will only have one data sheet associated to it. Again, my temperature indicator, same thing. I have one for my sensor as well. This sensor is associated to that one data sheet. Now what makes loops different is a loop calibration means I'm calibrating a cluster of instruments. For example, I may have a temperature indicator panel in a boiler room. And when I perform a calibration, I will input a signal at the very sensor. I'll put a pressure into there, and I'll read, or pressure or temperature, and I'll read that indication in the control room. So if that indication is correct, then that means every component in that entire system, the sensor, the transmitter, and the indicator, are all working correctly and are all calibrated. So when I calibrate the loop, I'm calibrating a cluster of instruments together. And if it passes, we're good to go. If, for example, that loop calibration fails, then I have to find out what component within that loop was the failing component. By associating with the loop up here, the loop data sheet, I also associate each individual component's data sheet as well. And you notice that only one of these is required. The loop calibration has its own data sheets required. And we'll see in a little while when I do the work order for this that on the data sheet at the work order level, if I perform a calibration on the loop itself and those points are okay and it passes, I don't have to do the remaining data sheets. They're optional. But if the loop fails its calibration, then I have the other remaining data sheets there on the same work order. I can do each one, calibrate each individual component, and find a defective one much faster that way. That's Job Plans Cal. One other very important thing about Job Plans Cal, let me go back to the Job Plans tab here, is that the Job Plans Cal application has revision control. So when I create a new job plan and activate it, it becomes locked down in a read-only format, and I cannot make any more changes to it. If I need to update this job plan, I have to go to Select Actions and choose the option that says Revise Job Plan. What this does, it essentially duplicates the job plan and makes a new copy and gives it the status of pending revision. That job plan is editable. So if I were to revise this, it would go to revision number 1, be pending revision for status. I can make my additions or modifications to it and then reapprove it again or activate it, and it would go to active. At the same time, my original job plan, revision 0, would be changed from active. It would go into revised status. And revised is basically a historical status. It's there forever for you to review and as a reference, but you can no longer use that particular revision job plans. You only can use the new one. So this is going to be good revision control for job plans. See, moving on, I'm going to click on Go To. And from Go To, we'll slide down to Planning again and slide over to Datasheet Template. And let me pull out an example. And I'll pick on this one. Now the datasheet template is really the heart of Maximo's calibration. This is where you configure the datasheet, which will be copied to the work order. And this sets up your exact calibration points, and not only the calibration points, but the tolerances as well. This whole thing is copied to the work order where the calibration is actually performed. Now you notice a couple things off the bat. This also has a revision control. So once you create a datasheet and activate it or approve it, it's locked down read-only. The only way to make a modification is to go to Select Actions and revise the datasheet. I'll revise it, gives it the next incremental revision number, and becomes pending revision. Once revised and approved, it becomes the only approved datasheet, and the old one becomes a revised one, which is basically kept for historical reasons. So I made a very simple datasheet here. These can be very complex. You really have to go to your system technical manuals for the instrument being calibrated and see what they want, how they want it to be set up, what the tolerances are, and everything. There's a lot of calibration theory into this. There's probably a lot more stuff here that you really need to have for most of your calibrations, but they're available to you. I made a very simple one up here. I made a basic 3-point calibration, which is pretty standard. I could have made more points. You could have 5 or as many as you want to. You create all of this. Now, I'll just show you a couple things. Under the asset functions, I only have one function. It's a TI analog. And I'm going to click the detail arrow to open this up. You can set this up with up to 4 tolerances. Now, you may not use all those tolerances. You may only use 1 or 2 or 3 or however many you want to, but they're there for you to use. And what you'll basically do, you set up asset function 1, and it's a calibration point. And my options are either it's a calibration point, a function check, or a dynamic check, one of those 3. And I can set my basic information here. Down below, I'm going to set up what my points are. And I may put things like my input range, in this case, -20 to 93 degrees centigrade. The minimum field resolution is how many digits to the right of the decimal point you want to record. If I have a minimum resolution of 2, that means every reading I enter I have 2 points to the right of the decimal point, or 2 zeros in there. If the reading is 20, it has to be 20.00. It will enforce that. In this case, I got my range limit -1 to +1, percent of span. It could be percent of span, or it could be engineering units, or several other values in there. Again, your documentation for that instrument will tell you what the tolerance should be. So input range, output range, process unit, scaling factor. It can be used for a number of different things. So you have the output limits clip, square root of input, which is used for a lot of flow indicators, and my tolerances. Usually the tolerance 1 is the tightest tolerance. It's most restrictive. In this case, it's -0.5 to +0.5% of span. And the status, if I take a reading that's within those 2 values, it will automatically have a status of pass for that point, or that reading. If I'm outside my first tolerance, but within my second tolerance, and the second one's a little less restrictive, it's -1 to +1, then I'll have the status that changes to adjustment required. This allows me to check my as found readings, and if I'm outside my first tolerance, but within the second tolerance, it allows me to make an adjustment to improve that output. So I can make an adjustment, and then my as left may be in spec then, or in tolerance. If I get outside my third tolerance, -2 to +2, if it's that far out, then the status of the reading goes to failed, which means that calibration has failed, and I have to take some kind of corrective action and recalibrate again. So this is the way the tolerances work. And this is set up one time, and once you set that up, then you'll create the different readings or points. Now each point below here, you'll see my calibration point. If I open it up, it will tell me all my specifications. It says nominal input, desired output. So in this case, I had a resolution of 1, or excuse me, of 0 for my output, so I don't need to have any values to the right of the decimal point. But for my nominal input, just had a resolution of 2, I gotta have at least 2 decimal points in there. And it gives me my tolerances. The limits are from -8.87 to -11.12. Those are my tolerances calculated out for me automatically by Maximo. And my tolerance 1, my tolerance 2, my tolerance 3. Okay, so these are my different analog points. Once this data sheet's created and you approve it, it's ready to go. And you must, again, we must go to the job plan, and you associate the data sheet to the job plan, and then to the actual asset or location. There's a Work Assets tab also, where you can see what assets this data sheet will go to. and it's my Datasheet Template. Probably the most complex application within the entire calibration functionality and within Maximo. So we're going to move on here, go to my next application to look at. Go down to Preventive Maintenance. Now there's two calibration applications here. One's PM Cal, the other one's Master PM Cal. We're not going to talk about the Master PM Cal because it, like the Master PM, are not used very often. And there's not much change between standard one and the calibration one. So I'm going to click on Preventive Maintenance. This has changed a little bit. And let me pull an example here to look at. Now the PM is very similar to the out-of-the-box standard PM. Not a whole lot's changed. Basically, you have your PM ID, description, your location, asset, or route. The only big difference is you have the capability now of selecting a work type of cal. Cal is very important because it has internal functionality within Maximo. That's how it knows what the calibration history is by that work type. So you always should be cal if it's a calibration work order. Pretty standard, last start date, last completion date, description. All my dates are about the same. If I click on my frequency tab, the only real difference is the extended date. We saw that in the organization's cal application, you set how many times this PM can have the date extended without requiring supervisor approval. That's a real big difference between the PM cal and the standard PM application. Other than that, they're pretty much the same. Select actions, there's not even much up here that's different. In fact, nothing's different. So this really, the PM cal, what it really does, it takes again, it'll take your job plan cal, take your data sheet, and when the time is right, it'll create a work order for that specific location or asset on your PM, and give it that calibration job plan and that calibration data sheet, and create the work order for you. And then it tracks how often it's due. So this really is your schedule to get all that stuff done. Click on Go To. Now we'll go over to Tools now. Tools are listed under Inventory. So under Inventory, we have Tools, and you have Tools Cal. You have Stock Tools and Stock Tools Cal. Stock Tools Cal. I'll click on Tools Cal. And we'll pull out an example. The tool record is basically, it has a tool ID. This standard value appears as a tool ID. This is actually located in the inventory table or the item master table. It basically has a different type of item, okay, called, instead of an item like an inventory, it has a type called tool. What this does, these really are your calibration standards. It's the only time I really see these used for calibration standards. And a couple things you'll always find is the tool ID used for calibration standards will have it checked as rotating, and you'll have this button checked over here for is MTE, is measuring test equipment, and have a MTE classification, in this case primary standard. So my calibration details really the only difference between the standard tools application and the tools cal application. Now I can indicate if this is calibrated internally in one of our own shops, or if it's sent out to a vendor, or if it's a buffer solution. I mentioned buffer solutions are you buy these solutions that are basically have a certain value associated to them. It could be a pH. I usually buy pH buffers in 4, 7, and 10 pH, and use that for the calibrations. This tool ID will be associated to individual asset records, and the individual asset records are your actual standards by serial number. So if I had a calibration tester tool ID right here, I may have 10 different calibration testers in my shop. Everyone has its own asset record with its own serial number, and everyone's tied to this tool ID as a rotating item. That's the way the tools work. Let's see what else we got. I'm going to click on Select Actions. These are all standard inventory options right here. Nothing different there. Only difference is this calibration section in the middle. That's Tools Cal. Very important because the Tools Cal goes on a work order on your Plans tab. This is what you're actually going to select, saying I use this specific tool to perform a calibration. And then after I select the tool, I'll pick out the individual asset record associated to the standard I really used. So we'll click on Go To, and the last one we'll talk about is next to last one. We'll go to Tools again, Inventory, Tools, and Stock Tools. And Stock Tools is a way to manage your tools. It basically works the same way as the out-of-the-box Stock Tools application. And what it really is, this is a clone of the inventory application. So just like in inventory, you'll take an item master, add it to a storeroom, and then in the inventory application, you'll manage the items within that storeroom. Stock Tools allows you to manage all the tools associated with that particular Stock Tools storeroom. So in this case, I got the central storeroom, and this is for my calibration standard. I can actually issue these out to people and have them returned. So I may issue the meter out to somebody, they'll perform a calibration, then return it back to the storeroom. And what's nice about this is if I click on the Rotating Tool Assets tab, I can see where every one of my assets by individual number. Now every asset number is uniquely different. I can see where they're all located out there in the organization. Now in this case, every one of these tools have their own asset record, and they're all located inside a location called Calibration Shop. This, to be quite honest with you, Stock Tools is not used all that often. Most calibration shops have the standards already stored in their shop, and they don't require anybody to check them out or sign them out or sign them back in. So it's an option available to you if you feel the administration is worth it or not. So these are just a quick overview of all the applications that make up the calibration, except one. And this one is the last one is really the heart of the whole thing too. I'm gonna click on Go To, down to Work Orders, and I have a standard work order tracking and a work order tracking Cal application. So I'm gonna open up work order tracking Cal. And pull out an example. I've got one in here. Yep, here's my example. And I forced to generate a calibration work order, and I can always tell because it says Cal up here. It's the way it's generated. It's generated and waiting for scheduling status, and that can only be done by generating it from a PM. This is checked off as loop calibration because this is a loop calibration. And I've got my location up here. It's my loop itself. I got temperature control panel boiler is a loop, and I made up a location just for that loop. Other things, it's got my job plan, but also includes my job plan revision. So I know when I generate this work order what revision of the job plan is on it. I may look back at old work orders and see some of revision 0, and there may be some newer ones that have revision 1 on it. It's got my PM number here and my frequency once a year. Let's see what else we got here. Everything else is pretty much standard out of the box Maximo work order tracking functionality. So let's click on Select Actions, see what's up here. We have some other things here. We have toward the bottom here, we have the check tool status. I can check the status of a tool. I can review data sheets. I can perform a tool spot check on my standard. I can view calibration history for the asset location on the work order. These are strict calibration functionality right here. The really heart of this thing is my datasheet tab. So I'll go to my datasheet tab and open it up. This is where you actually complete your calibration. You'll input your correct input reading to your instruments and verify the output reading, and you'll record all that down here as the as found, as left points. So these are copied off my data sheet. So when I put this in the correct status, I can actually edit all these. Right now I can't edit them because I'm not in the right status. But once I initiate this, I'll perform my calibration, and I'll enter my as found, my as found input, as found output, as left input, as left output. When I do all that, it will automatically calculate the status for me. So if I'm within the correct tolerance, it will calculate the status. I may enter one as found, and it may come up with the status of you need to adjust it, in which case I can adjust it, and my as left output may be okay then and pass the calibration. This is the important part, is the as left input and output. So, or it may just fail it. Now, we mentioned before that for loop calibrations, and we'll complete this out in a little while, is that only one data sheet, even though I assigned 4 data sheets to that particular location at the job plan level, only one is required. And so this top one is my data sheet for my loop by itself. Okay, so if I perform a calibration on loop and it passes, I don't have to perform any of the other ones for the components. Now, if I perform my loop calibration and it fails anywhere, then my other data sheets are here. I can just select them and go ahead while I got all my equipment out and calibrate the transmitter. I can calibrate the indicator. I calibrate the sensor. Now, when I calibrate each of these 3 instruments, I will most likely find one that's out of tolerance. So if my overall calibration of my loop failed, it's because one of these components here failed. So if I perform all my other calibrations and find out that my indicator failed, well, then I can take corrective action on the indicator, either repair or replace it, and then reperform the entire loop calibration again as a final check to make sure everything's okay. So that's the difference between loop calibration and a standard calibration is I get more than one data sheet. I don't have to do one if it passes, but if it does, I can do more. So that's basically my how my loop calibration works differently than any other calibration. Okay, so since we got it open here, we'll go ahead and complete this calibration now. And just like any other work order, I'm going to back up a little bit and open my work order up. And I'm gonna assume that this has already been planned out. It's a PM, so it's already planned out. It's been scheduled to do, and I've been assigned to do the work. So again, this all goes back to your own maintenance processes. I'm gonna put this in the in progress status by checking the initiate work order button, and we'll put it in progress. And you'll find out that pretty much all calibration functionality has an e-signature attached to it, and it requires me to put in my ID and a reason. I'm going to put on here calibration demo. That's my status change to in progress. Okay, now we're in progress. Now I'm going to go to my Datasheet tab. Okay, now you notice when I went to in progress, unlike before when we looked at these, I can edit these now. All my input readings can be edited right now. So the whole idea is I'll select my correct data sheet, in this case my loop data sheet, and I see that's required. And when I do that, I'll see my calibration points below that. I'll use my instrumentation to input the correct values, my nominal input, and verify my outputs. And I'm going to record my as found input, as found output, as left input, and as left output. Once I input all these readings, it should calculate out for me whether or not that point passed or failed. And if any one point fails, then the whole calibration fails. If they all pass, then the entire thing passes. So I'm going to put in my first as found input. Now I'm going to make this a passing calibration. I'm going to put in a value of 10 and press the tab key. Now you see I put in the wrong reading. I didn't look closely enough, and my nominal input is minus 10. My desired output is minus 10. So we got the organization set up to show an error message if I put in the wrong value, and it may be a correct value. I may have actually got that reading error, which tells me that I'm out of tolerance. So I'm going to say okay, put that reading in again. My nominal value is minus 10. I put minus 10 and tab out. See what happens now. Nothing accepts that. But you also notice that it automatically added the 2 zeros to the right of the decimal point. That's because the field resolution is set up for 2. It must have those 2 zeros in there. And my as found output is supposed to be minus 10, so I'm going to put minus 10 in there and tab out. And it doesn't add any zeros there because the resolution was 0. It doesn't require anything beyond the decimal point, the right decimal point. Now my as left input, I'm going to put a minus 10 as well. Tab out. It adds my resolution, 2 zeros in there. My as left output, I'm going to give it a minus 10 as well. That was a perfect calibration. That's my first point. I'll go back and do all of them like that way. Click on my asset function, still on asset function 1. My calibration point is 2. And this reading should be 36. I'll put 36 in here. 36.05 and tab out. Still within tolerance, I didn't get any error message. My as found output is also 36, 36.07 on there. And my as left input, give it 36. 36. And as left output, make that 36 as well. Okay, and now my last calibration point, and my set point is 81 in this case. I'll input my 81, and I'm going to type in 81, tab out. It pulls in my zeros for me. Output, I'm going to put 81.06, tab out. My as left input, I'm going to put 86.01. Oh, again, I typed it outside my range. I can only go between 79 to 82, and I put in 86, another typo. So you will get a warning every time you're outside your limits. And it could be because it's really out of limits or because you have a typing error. That was okay. Now my last point is my asset output. Put 86 on here. Oh, 80, almost did it again. 82. I've got my readings in there now. Now, this didn't require anything else. Normally, sometimes you have function checks, dynamic checks. Sometimes you may have a second calibration function for discrete checks. And discrete checks are basically switches and alarms. So if I'm reading a temperature indicator or a pressure indicator, maybe at 100 psi, it gives me an alarm that says warning. And maybe at 125, I get a high pressure alarm. That's an indication of a discrete component. And I may have to calibrate that by increase my input signal to the right point and making sure that set point goes off. That would be discrete. And when you set your data sheet up, you'll set them up as function 2 might be discrete checks. Okay, and you have 1 or 2, how many calibration points there are. In this case, I kept it simple. They're all good readings. So now I'm going to click on the Save button to save this record. So go to the very top, click on my old floppy disk. The record's been saved. Now you also notice what else happened. When I save this function 1 here automatically changed to as found readings were passed, as left readings passed. Now up here my data sheet overall passed. So this tells you the indication of the function. We only had one function, as a function 1. If I could add function 1, 2, 3, 4, however many there are, it will tell me the as found and as left status for both those. In this case, both pass. And also, if all your functions pass, then your overall data sheet passes, as found, as left. So if I have 5 functions and 4 of them pass, 1 doesn't pass, well then my overall data sheet failed. It automatically calculates that out for you. So this is how a calibration technician enters a reading. Once I calibrate this, I'll enter all the readings, save the record, and I'll see it's passed. Now, like any other work order, you need to fill out a few more things to complete this work order out. Next thing we're going to go to is my actuals. Now my actuals tab, here's my labor. So I'm going to just click new row and put in my labor. That's standard Maximo right there. I'll put in my hours, say 3 hours. So first thing I fill out, as usual is my labor. I'm going to save the record. I didn't use any materials here. I'm going to click on my tools tab. Now this is where it's very important here for calibrations, more so than anything else. The tools tab. This is where you're going to input. You list your standards you're using for this calibration. So I'm going to click on the select plan tools. And there's my calibration standard. I'm going to select that. Say OK. Now I picked out my standard. Now I cannot save this record as it is. I must do some more information first. So I'll click on my detail button over here, open that up. And you'll see that because we have our organization settings set up correctly, that not only do I need the tool here, the calibration standard, but I need the actual rotating asset associated to that item, that tool ID number. So I'm going to click on my arrow here and open it up. Select value. And these are all my tool standards in my cal shop that can be used for this calibration. I need to pick out the one I specifically used. So I'm going to click on number 6 below here. When I did that, it also opened in a due date. This thing is due calibration today as well. This is important because you can configure this not to allow a past due date tool to be used. And this saved my enter date, and that's my date used, or date due, and date used. Now, depending on how you configure your setup here, I can actually change this date. It could be that this is not correct, and I know it's not due till the 9th and just hasn't been updated yet in the system. So I'm going to make sure that my current one, based on a calibration due date on a sticker, is correct. And here's my date used, my date due for my instrument. And I want to record this. This is my indication that this calibration was performed with a valid standard. So I'm going to set that up, hit the save button, make sure everything's okay. And if it saves, you're good to go. And I've associated my calibration standard to my calibrated instrument now. So the last thing I want to do is change the status of this work order to complete. Now I use my button to do that. Complete the work order. And it goes completed. And it wants another e-sig. And we'll say OK on that. And calibration is completed. I'm in the status of complete now. And it wants to make sure, because the way we have this set up there, I could not complete this without putting a tool in there. It requires you put the correct tool in there before you can complete it. So we've Taking the work order, we went to our data sheet, we've entered all of our different data point readings, and it verified that they were all in spec. Changed my status to pass for my data sheet, pass for the function. Then we entered our actual labor and our actual tool, our standard tool ID, and then our actual standard asset record. We had to put them both in here, and we completed the work order out. A quick check up here in my select actions, and see what all we have here. Toward the bottom, I got view calibration history. We'll take a look at that real quick. View calibration history, and we'll give it a date. We'll go back to I'll go back to not too far back. I'll go to October 25th as my from date, and I hit refresh. Wow, nothing shows up. And that's because there's 3 tabs up here. One says Asset Calibrations, Location Calibrations, and Loop Calibrations. And we know that in this work order we did Loop Calibration, which is based on location. So there are no assets in this calibration, but if I click on the Location Calibrations, I'll see all the work orders done against this particular asset, or sorry, against this location. And I can see them all this right here. Now I see multiple work order numbers here. That's because these were loop calibrations. We just did 1177, but we only completed one data sheet. So the one data sheet for the actual loop itself passed. There's my pass left right there. I didn't have to do the individual components. If I did do the individual components, they would have all their data right here as well. So that's the way a loop works again, because I only care about the loop. And if everything passes, I don't care about the individual components. So by selecting that loop calibration, I can go below here and see all my readings I entered, my input and output readings. So this is my calibration history. And loop calibrations pretty much tells you the same thing as the location calibrations, because almost always the location is your loop. Now there could be situations where you have a different loop or a different location with components pulled from various other places. Not done too often, but could be. So a lot of the same information in both tabs right here. I'm going to click on OK to make this go away. And let's go back to select actions, see what all is up here again. And go down below and tool spot check. I can add a tool spot check to this. Hit Neuro and rotating asset. I'll only pick one out here. And there's my standards. This only provides their standards. I use number 6. So I'll pick number 6 out here. And this is optional. It's one of those extra things you can do. Standard rotating asset status. It passed. If I do my spot check and it passed, I'll be good to go. What was my check type? We'll say it was a pre-check. So before I performed the calibration, I did a pre-check on it. Comments, if I want to make any comments, other information, I'm going to hit OK. That's a spot check. Sometimes people will, even though the instrument's calibrating, has a calibration sticker on it, they may want to do kind of an operational check or a spot check to make sure it still works. Doesn't check the accuracy of the instrument, just make sure it's still working. Spot check, go back to select action again. And view calibration history, we did that. Check tool status, we can do a quick check of the tool status. Pull it out, select the value. Again, we'll put up STD up here. And pick number 6. And refresh. And here's my actual calibration meter. The next calibration due is on 9/1 of 2012. So this is a quick check of the tool you used. You can pull up the tool out and see what is the status in Maximo. There's a serial number. You might want to verify that. It's active. It's a quick check on the tools that will be used to perform the calibration. I'm going to click cancel on this. And that's pretty much all the options available under select actions. One quick check. And that's pretty much it. Check tool status, review data sheets. Those are my different options available under work order tracking. So we basically talked about all the calibration applications: Organizations Cal, Locations Cal, Assets Cal, Job Plans Cal, Datasheet Template, Preventive Maintenance Cal, Tools Cal, Stock Tools Cal, and Work Order Tracking Cal. And we walked through a basic calibration, a scheduled calibration. The PM work order was generated from a PM application. We went to the work order, put it in progress, entered my datasheet readings, saved it. It told me what the status was of each point and the overall datasheet. I completed out the work order. So that calibration is complete. Again, loop calibration is a cluster of instruments all calibrated together as one unit. And if they all work together right and the loop calibrates, no further need is required to calibrate the individual components. If any one fails, then you can calibrate the individual components and find which one is bad. This pretty much concludes our presentation on the calibration functionality within Maximo version 7. We'll go back to my Start Center. And this is a good place to exit. Thank you for your time. I hope this helped you out a little bit. If you have any questions, please contact us at Projetech. Thank you. Please visit our website at www.projetech.com and view some of our other training videos. And if there's anything we can do to help you, please contact us. Thank you.